Hello everyone, welcome to my class. In this video I'll be talking about motion graphs. They say image speaks louder than words, which means our brain processes the image more quicker than words. Therefore, describing motion with graph is the best way. In this video we'll be talking about two types of graphs, distance time and speed time graphs. So let's start. Motion time graphs. In here we will see two types of graphs, distance time and speed time graphs. So distance time graphs represent how far the object moved in a certain time. And the slope here represents the speed. Because you know from the graphs, slope is equal to delta y over delta x. Delta y is distance and delta x is time. So the slope is speed. And slope up in this graph is traveling at a constant speed. So as you can see, in 2 kilometers has traveled in 2 hours. 4 kilometers has traveled in 4 hours. So therefore it is a constant speed. The horizontal lines in distance time graph represents stationary objects. So as you can see, distance is not changing during this time period. From 10 to 12 hours, there is no distance change. So it is stationary. Again, when distance traveled in time, you can see 10 to 14 kilometers has traveled from 12 to 16 hours. Yeah, so it is also constant speed. So slope is the speed and speed is equal to distance over time. So we can calculate the speed from graph. From this point to this point, it is how many hours? 2 to 10, difference is 8 hours. And distance traveled in 8 hours is 10 kilometers to the second kilometer. So difference is 8 kilometers. So speed is equal to 8 kilometers over 8 hours. And answer will be 1 kilometer per hour. So during this time, the constant speed was 1 kilometer per hour. As we can represent the motion by distance time graph, we can also represent by velocity time graph or speed time graph. Velocity time graph or speed time graph shows how object speed change as it moves. So when you do questions about velocity time graph or distance time graph, every time check y-axis, because students usually confuse about velocity time graph and distance time graph. So if you don't check the y-axis, you might consider this is a distance time graph and you can think that this slope represents the speed. In the velocity time graph, the slope represents the acceleration because velocity over time is acceleration. The slope up represents the steady acceleration. The horizontal line represents the steady velocity, constant speed. And sloping down represents the constant deceleration, slowing down. So acceleration is equal to V final minus V initial over time taken. From velocity time graph, we can calculate acceleration. For the first part, let's calculate the acceleration. Velocity final is 3, velocity initial is 0, so difference is 3, and time taken is 2 seconds. So 3 meters per second over 2 seconds will be equal to 1.5 meter per second or 1.5 meter times second to the power of negative 2. Well, let's talk more about velocity time graphs here. Acceleration can be calculated by gradient of velocity time graph, as we just said. Remember, gradient is the difference up divided by the difference across, which means m is equal to delta y over delta x. Yeah, x-axis over y-axis is the slope. So slope in the velocity time graph is acceleration. So here, constant acceleration and constant velocity. Again, constant acceleration, then constant deceleration. So let's calculate the acceleration for each of these 4 sections. 1, 2, 3, 4. So first section, final velocity is 40, initial velocity is 0, difference is 40 over time taken is 10 seconds, so 40 over 10 will be 4 meter per second square. In the second section here, velocity is not changing during 10 seconds, so because of no velocity change, acceleration is 0. In the third section, final velocity is 20, initial is 0 during the 10 seconds, so accordingly, acceleration will be 2 meter per second square. In the last section, final velocity is 0, initial velocity is 60, and during 20 seconds. So negative 60 over 20 will be negative 3 meter per second. Negative 3 meter per second represents its deceleration. Alright, one more thing which we can deduce from velocity time graph. On a velocity time graph or speed time graph, the area under the line is numerically equal to the distance traveled. So this area is equal to distance traveled. What is the formula for area? Area is base times height. Yeah, base times height. For the triangle, remember that the area of triangle is 1 over 2 times base times height, because half of this rectangular. Well, let's see the area under the lines. So first section is 200 meters square. Why? Because 40 times 10, 400, half is 200 meter square. Second, here we have height is 40 and base is 10. This is the rectangle, so 400 meter square. In this area, this rectangle also 400 meters square as this, and this triangle area is 100 meters square. 20 times 10, 200 meters square over 2 will be 100 meter square. The last section area is 60 times 20 will be 1200 over 2, since it is triangle, and area will be 600 meter square. So total distance traveled by the object is, when we add up all this area, will be 1700 meters. So distance traveled by object equal to the area under the line. Well, that is all for this video. I will see you in my next videos.